Hello, Algebra 2. We are doing, this is called Day 10, Unit 2, Day 10, the quadratic formula. However, I want to go back to Unit 2, Day 9, just to finish what we started in class, because I know we kind of jammed in a lot when I saw your list. So my period 5, we had gotten through some of this. My period 7, we hadn't gotten to this yet. So if you're period 5, you can fast forward through a couple of these, but make sure that you watch me with completing the square. I'm only going to do I'm only going to do one from each. I'm going to do 5, and I'm going to do 6. So we're going to do 5 and 6. So with the square root method, now what we talked yesterday, let me go back, is that we're solving for quadratics. So we did factoring. You can do other methods. You can do square root method. You can do completing the square. And then the actual lesson day today is quadratic formula. Okay, so if you're solving by using the square root method, it says isolate the square root. So when I look at 5, I see that the x is inside a squared. So I'm going to isolate by dividing by 2, because I got to get rid of the 2 on the outside of the square. And the square root method is just what it says. It's like you're square rooting, you're undoing the squared. So when I undo, and I always put a plus minus on the outside of a number, when I create a square root in front of or around a number, I put a plus minus. Because it could be negative 10 squared is 100 or 10 squared is 100. So that gets rid of the squared. So I've got plus 10, and I actually have a minus 10 as well. And then I solve. Right? So I've got x is equal to 15. And then I've got x is equal to negative 5. So my solution is I've got a negative 5 and a 15. And those are two real unequal roots. Okay. If I solve by completing the square is another method. So you've done completing the square. That's why I didn't want to belabor this method. So let's just look at 6. And I want to show you that we're going to actually have an imaginary solution here too. Because remember, I described to you kind of briefly that if I were to take a quadratic and I were to graph it, if it doesn't touch the x-axis, we have imaginary solutions. So when I look at 6, this is what we're going to do. And remember, we did this with the parabolas when we were trying to put it in conic form, and we did it with the circles. So you're going to isolate the c value, because remember, it's ax squared plus bx plus c. So the c is the 36. I'm going to leave a space. Right? And then I've got that b value. That b is negative 8. And I'm going to divide it by 2. And I'm going to square it. And I am adding that 16 to both sides of the equal sign. So, and I've got x squared minus 8x plus 16 equals negative 20. And then you're going to do the factoring part. You're going to factor that quadratic because you created a perfect squared trinomial, which means that x minus 4 squared, x minus 4 times x minus 4 would be x squared minus 8x plus 16. Remember, it's this number here. Okay. And then you're going to do you're going to do the piece now. So we left it like this for the conic versions, right? If it was a circle, we left them, or if it was just a regular parabolic form, we left it. We factored out the right side. But for this one, we're solving for x, so we got to get rid of the squared. So we're going to do, now look what I did. I created a square root around a negative number, so then you go, oh, that's an imaginary solution. And it's got to have a plus minus. So let me pull it up here. I got x minus 4 equals positive or negative the square root of negative 20. Now remember what I said, you make this a positive and you pull the I out. right? Because then you know it's imaginary. And we're going to simplify. So 4 and 5, right, are factors of 20. 4 is a perfect square. The square root of 4 is 2, so it comes out 2i radical 5. And then I'm going to add 4. And I've got x equals 4 plus or minus 2i radical 5. Now there's that a plus bi form, see it? So when I add the 4 over to the other side, I can't, that's a real number. I can't combine it with an imaginary. So my solution is 4 plus or negative plus or minus 2i radical 5. Let me try that again. And the nature of the roots is 2 complex solutions, okay? So I will tell you for 7, I'm not going to do the whole thing. I promised you I wouldn't belabor the method. But I will tell you that if, in order to do completing the square, you have to have the a value equal 1. So you would divide out completely a 3. And because I got to get rid of that. And then it would be x squared minus 4x minus 8 equals 0. So the 3 goes away completely, and then you start the method, okay? All right, kiddos, let's go to the quadratic formula. And it does say discriminant. You're going to eliminate discriminant this year because of COVID. We had to break down some of this unit, and that's the one we're not going to do. Okay, so let's talk about these. It says, which method would be the easiest to use in order to solve the following quadratic equations? You do not need to solve each, just name the easiest method. So for A, I would actually just, for me, because I like to factor, obviously. I'm a math teacher, so I like all that stuff. So I would look at it and go, can I factor? That would be the part I'd look and say, okay, it's a quadratic, can I factor? Do I have two numbers that multiply to be 7? That also add to be negative 6? And I would say, yes, I do. I have negative 7 and positive 1, so I can factor that method. I can use the factoring method to solve. For B, it's not really in factoring mode, right? It's not all distributed out. But I do see that the x here is got a squared, so I would actually do that square root method. Like, remember how we did up here? I'd look at that and go, I can do the square root method here. Because I could divide by 3, right? Divide by 3, isolate it, and then the opposite of squaring, square root. So here I could do the square root method. Okay, in C, I could, let's see, again, I'm going to look at it as a trinomial. I'm going to say, is there anything that multiplies to be negative 4 that adds to be negative 3? And I would say negative 4 and positive 1. They add to be negative 3 and they multiply. So I would actually do factoring again for that one. Okay, so that's just a little reminder. Now, for A and C, you actually could do completing the square too. I have some kids that really like that method, so they automatically go to completing the square. I don't care if you can factor it. You can do completing the square as long as the A value is 1. And you like that method, go for it. Okay, now consider the solving this one. Okay, we got a 3x squared minus 4x plus 2. So I would look at it and go, can I factor? And this would be a grouping method. So I would say 3 and 2 multiplied by 6 and negative 4. And I would say, boy, do I have anything that multiplies to be negative 6 that adds to be negative 4? 3 and 2, 6 and 1, they don't add to be negative 4. So I can not factor. Because there's no grouping. There's no grouping of values. Okay, so that would be how we would do it. So we can't do the grouping. We can't do the factoring. I could try and do, I could divide out the 3 and do the completing the square, but that's a negative 4/3 I'm going to do. So I would say completing the square would be hard. It's difficult because we have fractions. right? So when I divide out for 3, I get negative 4/3 and 2/3. And fractions are difficult. Okay, and then we can't do square root because we don't have a, because we have x squared and an x, right? Which the only way, again, you can do that square root method, let me show you. Remember, looking at form 5 is if this is like isolated, if it's just an x squared, which we didn't do that one, but, or it's an x minus 5 squared with no other x on the outside. So all else fails, do the quadratic formula, okay? So this is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, all right? Now, I have a couple on the back that I'm going to leave. I'm only going to do one of these. You've done it in Algebra 1. You've done it in a little bit in geometry. So I'm going to do this one with you, and then I'm going to give you the answers to the other two in the back, and then you can try them. All right, so that you don't have to see it over and over and over again. Okay, so when I do the quadratic formula, we have to look for we have to define what A is, what B is, and what C is. A is 3, B is negative 4, and C is 2. And then literally just plug them in. So I put in negative 4 wherever there's a B. So negative 4 squared minus 4. A is 3 and C is 2 all over 2 times 3. And then when you do this, this is what I want from you. I want you to break it down. So I don't want you to do the square root yet. I want you to do inside the square root in your calculator. So see that red box? I want you to type just that in. No square root, just that. So you're going to say x is equal to 4 plus or minus. Plug that in your calculator. So when I do negative 4 squared minus 4 times 3 times 2, I get negative 8. And then 2 times 3 is 6, okay? So the reason why I want you to do this is because I want you, if you were to do with a square root and all that, it would come out to be some crazy decimal. I don't want that. I want you to tell me I want you to keep it in simplest radical form. And I want you to tell me, is that an imaginary? And if you were to try and do that with in this calculator with a square root, it would come out to be an error because it is an imaginary. And the calculator cannot do square roots of negatives. So we're going to just do simplifying. We're going to say 4 and 2, right? This comes out as an I. And so I've got 4 plus or minus 2i radical 2, because that square root of the 4 comes out as a 2, all divided by 6. And then, to take it further, this is required. When you have an imaginary, I want you to break them down. I want you to separate the dividing by 6. It must be separated so that you've got, here's your real number, and here is your imaginary. Okay? And then what we're going to do is we're going to simplify from there. So we're going to do 2/3 plus or minus, because these reduce. Oopsie. 3. And you have your answer. And that's it. And when I ask you like the nature of the roots, you're going to say there's 2 complex solutions. Okay? That's all. I'm going to give you these, and we are done. I'm going to tell you what the solutions are for these. Okay, plus or minus 2. So you can go ahead and try these two. Set this one equal to 0. So you got to make sure it's always set equal to 0. And this one's a -1 plus or minus I. So there's some reducing in that one. Okay, so give it a go. At least try one of those, and then you'll do your homework. And then when you come back to me, I can field some questions. Okay. All right. Take care. You know where to find me if you need some help. Bye bye.